So this is the circle bit part 2. Remember, this is everything you need to know about circles. Okay, how about if I wanted to find the area of a sector, or a segment of a circle, a bit of a circle? Let's just for argument's sake say I've got a circle here, here I go, round it goes, okay, and then using my ruler I draw you a bit of my circle. How about if I want just that bit in there? I'm going to do this a little bit freehand so you can see it. And how about if I tell you by using my protractor that that's 15 degrees? What's the area of this shaded bit here? What is its area? Now this is quite an advanced question. You might not even get it in year 10, but you'll certainly get it in year 11, and you might get it as an excellence question. Okay, so the first thing you're going to do is measure your actual circle. So here I go. Oops, this one's been cut off, so I'm going to start on the 10. And I'm going to go like this, and so I've got 15 and a half, 15 a bit more, 15 a bit more, 15 a bit more. I reckon that that's probably going to be it. So what's that? That's 5.6, 5.7. I want to call it 5.6. So the diameter is 5.6 centimeters. Please note that in exams you're allowed a 1 millimeter check. So if you look at this video and go, oh no, it's not quite right, it's 5.7. Well, I'm allowed 1 millimeter. Give me a break. Okay. So now I'm going to say my area of my whole circle is pi r squared. So that means that the radius is 5.6 divided by 2, which I can use my calculator for if I want to. I could work it out as well, but 5.6 divided by 2. For those of you who are very bright, I would suggest that you still use your calculator, because this is the sort of thing you get wrong in exams. All right, because you just assume, oh, 5.6, that's going to be 2.8. You just assume it. Okay? Oh, it is. That's fine. That means that I've confirmed to myself that I was clever. Yeah? But by doing it on my calculator, I've avoided that silly mistake that people make, which costs you marks, doesn't it? Okay, so that's 2.8. So my area of my whole circle is going to be pi times by 2.8 squared. And I've already been through that in the other video, so I'm just going to do it for you. And that's 24.6300864 centimeters squared. Now I've written the whole thing out here for a reason. Now remember, I wanted 15 degrees of my circle. All I've found out so far is the area of the whole circle. Now, a whole circle is made up of 360 degrees, agreed? So all I've got to do to work out the area of the segment, or sector it's actually called, it's called a sector. So I'm going to write area of sector is going to be 24, and this is why I wrote the whole decimal out, divided by 360, which will give me 1 degrees worth, and times by 15, which will give me 15 degrees worth. So I've already got my answer on my calculator. Divide it by 360, times it by 15, bang, and I get 1.03 centimeters squared. And can you notice that this time I've made a massive mistake? Okay. No, the centimeters squared is right because it's an area, but what I should have done first is write the whole decimal out. Okay, and then rounded it to 2. That is correct rounding, by the way. Okay, to 2 decimal places, that is 1.03. Okay, so we're nearly where? We're 3/4 of the way around everything you ever need to know about circles. Okay, so we've found out the area of a circle, the circumference of a circle, the area of a sector. Okay, so the last thing then is we're going to do the volume of a cylinder. So if I give you a baked bean tin, yes. Okay, that's a very good question. The question I've just been asked is what's the difference between a sector and a segment? I'll show you. It's probably easier to show you than it is to actually explain it, to be honest, so I'm just going to draw it for you. So there's my circle. Okay, this bit here is called a sector. This bit here is called a segment. Okay? That's a really good question. Thank you for that. So the last bit we're going to be looking at today is the area, so the volume rather, of a cylinder, and I need you to remember that the volume of a cylinder is, well, a cylinder is a prism. Now, do you all know what a prism is? It's a shape that if I sliced it through, all the way through, every single slice that I made would be the same. In other words, it's got a uniform cross-sectional area, which is a very posh way of saying slice it up a lot and you'll end up with the same answer every time. So let's just draw ourselves our cylinder. Please just bear with me while I draw it. I think it's worth taking our time. And there we go. Mitchell's compasses are a bit loose. Mitchell, can you remind me to actually tighten them up for you? Okay, so there's a cylinder. Okay, now I take that radius there. Let's just say that radius is 2. Let's make the maths easy for ourselves. So that's 2 centimetres. So the first thing I'm going to do is work out the area of the top. So the area of the top is pi r squared. You notice I do it the same way every time. I don't cut corners, please don't. So what's the radius this time? 2. I just told you. Don't fall into the trap of thinking you've got to halve it because I told you the radius this time. Yeah? So what I'm going to do is write area equals pi times by 2 squared. Okay? Which is 12.3-ish, I think. Let's just check that. Okay? Pi times by 2 squared is 12.57. 0.56637061. I haven't shortened this because I'm going to use this now. Now, to find the volume of a cylinder, you find the area of the top and you times it by the height. So let's just say the height is 6 centimetres. So the volume is the area on the top times by the height. So that's 12.56637061 times by 6, which is, you not talk please, sir, behave yourself, is 75.3982239, or approximately 75.4, and this time it's a 3-dimensional object, so it's centimetres cubed. Okay, lines are a 1-dimensional object, so they're centimetres. Shapes, flat shapes, are 2-dimensional, so they have a 2 after them. Volumes are a 3-dimensional, so they have 3. So the key thing to remember from this is the area of the top times by the height, and that works also for any prism. It's the area on the end times by the height. Okay, and that's all you ever need to know.